In this topic, we are going to cover project number 3, Keylogging a system. In this lesson, we are going to use the Win32 API and C types within Python to implement a local keylogger. In order to do this, we are again going to use a number of Win32 API functions to set up a keyboard hook. And if we take a look at the Microsoft documentation, we can learn just what a hook is in this context. So here we can see a hook is a point in the system message handling mechanism where an application can install a subroutine to monitor the message traffic in the system and process certain types of messages before they reach the target window procedure. So what that means is that we can use a Windows hook to intercept, read, and process keyboard input events, and by doing that, we can create a keylogger. So let's get started by importing the modules that we need. And saving this. Next, we can open the MSDN documentation for the functions we're going to need for this keylogger. Get window text length A. Get window text A. Get key state. Get keyboard state to ASCII. Call next hook EX. Set Windows hook EX and get message A. We can close some of these tabs here from the previous project. And next, we need to create the function definitions for these Win32 API calls, which we are going to be using as part of this project. First, we can set up a variable for user 32. And now we can start with our definitions. And we need a handle. And the return type is an int. Next, we need get window text A. And here we can see the parameters are a handle, an LPSTR, and an int. And the return type is an int. Next, we need get key state. We need an int. And the return type is a short. Next, we need get keyboard state. And the argtype. And here we can see that the argument type is a 256 byte array that receives the status value for each virtual key. So let's define this keyboard state. of the necessary size. And the return type is a bool. Next we need to ASCII. And here we also need a pointer to that 256 byte array that contains the keyboard state. And the return type is an int. Next, we need call next hook ex. And the return type is an L result, which we'll define in a moment. Next, we need set Windows hook exa. And the first parameter is an int. However, the second parameter is a hook proc. And a hook proc is a pointer to the hook procedure. So we can find this. And here we can see the hook proc callback function is an application defined or library defined callback function used with the set Windows hook ex function. And the hook proc type defines a pointer to this callback function. And here we can see the syntax. So we can add this to our application. And the first parameter to cfunc type is the result, followed by the arguments. And now we can use this. We need our H instance and the D word. And the return type is a H hook. Lastly, we need get message A. And the return type which is a bool. And we also want to add a few constants here. For example, L result, define this as a C-long. And we also want to specify the type of hook we will be using. And the type of hook that we want to use is a WH keyboard LL, which installs a hook procedure that monitors low-level keyboard input events. And we also want to add a few constants. for the key down, return, and shift message and virtual key codes, because this will help us later with interpreting our data. And when using these functions, we are also going to make use of the KB DLL hook struct. And this structure contains information about a low-level keyboard input event, which is what we are going to hook. So we will populate this structure as part of our hook. And we can then use the data in the structure to identify which key has been pressed by the user. So let's include this class. We can add the fields for VK code. The scan code. Flags. The time. And the extra info. And when performing keylogging, it's useful to know the process the user is typing in. And so we can use the Win32 API now to get information about this foreground process. So let's create a function here. Get foreground process. And we can use another function which doesn't take any parameters. Get foreground window retrieves a handle to the foreground window. And the foreground window is just the window with which the user is currently working. Foreground window. And now that we have this, we can use getWindow text length A to retrieve the length in characters of the specified window's title bar text, because we want to know which process, based on its text, that the user is currently writing in. So we can get the length. And we can pass in our handle, which we have. And now that we know the length, we can use getWindow text A to copy the text of the specified window's title bar into a buffer. So to do that, we first need to create our buffer. We'll give it a length based on the length of the text that we already know. Then we can call the function. And we can pass in the parameters, the handle to the window, the buffer that will receive the text, and the maximum number of characters to copy to the buffer, including the null character. And then we can return the value that's been written into the buffer. And we aren't, but should be performing some error checking here. And we can test this out. Fix a few typos here. Length with the G. Win types. Round window. And here we can see that we're now receiving information about the foreground process that we're currently working in. So this is working as expected. And so now we can set up the hook to start our keylogger. So in order to do that, we need to use the set Windows hook EAXA function, which installs an application to find hook procedure into a hook chain. So we can create our hook. And the first parameter is the type of hook procedure to be installed. The second parameter is a pointer to the hook procedure. So that means we need a hook procedure. And we'll just call that the callback, which we'll implement in a second. And we don't have a DLL containing a hook procedure. And we also don't have an identifier. So we can pass in 0 here as well. And now we need to create our callback. And we know that the callback needs to be a hook procedure. And so now we also need to create our hook function to actually hook and handle keyboard events. And this hook function will receive an encode, a W param, and an L param. And we can also make use of a global variable here to keep track of the last foreground process that we saw. And if the last one that we saw isn't the current process, we can update the last. And we can also print it out. And now we can start implementing the actual keylogger handler. We can check whether the pass value is the keyboard down code, which is basically checking whether a button has been pressed. And when a button has been pressed, we want to take that information and store it in the KB DLL hook struct. Based on the address. And from address returns a ctypes type instance based on this memory address that we're passing in. And next, we want to create a state variable to actually hold the state for all of the 256 potential virtual keys. And now we can use the getKeyState function. And this function retrieves the status of the specified virtual key. And the status specifies whether the key is up, down, or toggled. And so we want to know the state of the shift key. Because if the shift key is being pressed, then this influences what the user is entering. For example, if you press the 1 key and the shift and the 1 key, you will usually get a different result. Next, we can get the keyboard state, which copies the status of those 256 virtual keys to the specified buffer. We can pass in our state variable. And now that we have the state of the virtual keys, we want to know which key the user actually pressed. And the toASCII function can help us here because this translates the specified virtual key code and keyboard state to the corresponding character or characters. We can call this function. The first parameter is the virtual key code to be translated, which we have from our keyboard struct. Next, we need to enter our scan code, which is the hardware scan code of the key to be translated. Next, we pass in our state, which is a pointer to a 256 byte array that contains the current keyboard state. Next, we need a buffer to receive the translated character or characters, and we're just going to focus on a single character here. And finally, the flags, and we can just specify 0. And let's take a quick look at the return type of toASCII. If the return value is 0, the specified virtual key has no translation for the current state of the keyboard. If the return value is 1, one character was copied to the buffer. And if the return value is 2, then 2 characters were copied to the buffer. So let's make sure that n is greater than 0. And we're also only expecting 1 character here. We can check the code again to see whether the user has pressed an enter key. And if they have, we can print a new line. Otherwise, we just want to print out the key which the user has pressed. And we can use the string at function here and decode the bytes. And the string at function here from C types just returns the C string starting at the memory address as a bytes object. And the last thing that we want to do is we want to return the call next hook EX function. And this function passes the hook information to the next hook procedure in the current hook chain. And a hook procedure can call this function either before or after processing the hook information. So we can pass in the hook here, and then we can also pass in the encode, wparam, and lparam parameters. Fix typo here. And lastly, we need to use the getMessage function because this function retrieves a message from the calling thread's message queue, and the function dispatches incoming sent messages until a posted message is available for retrieval. So we can call this, and the first parameter is a pointer to the message structure, and we can use win types for this. We don't need to specify a handle. The lowest message to be retrieved should be 0, and the highest should also be 0. And now we can execute this. Fix a few typos by ref. And now we can see our keylogger in action. So if we go back over to Sublime here and press enter, we can see that the foreground process has changed. However, we have another typo, so let's fix this. So the keyboard state should actually just be a byte here. Let's try this again. And so now we can see when we type into Sublime, our keylogger is capturing these keyboard events. And if we hold in Shift, this also influences how the text is being displayed to the screen. And if we change our process, we can see that we're now typing into our new process, Notepad. Or if we try in Chrome, we can also see that we're now capturing all events that are entered by the keyboard. And you won't be able to press Ctrl+C anymore to end this process because we haven't included any interrupt code in here. However, if you press Control and pause, you'll be able to exit from the program. And there are Python packages which you can use to achieve a similar keylogging result. However, with access to C types and the Win32 API, you have much more control to use Python to directly interface with the underlying Windows operating system. But that's it for now, and in the next lesson, we are going to cover project number 4, buffer overflow.